Welcome to our next discussion. We are going to discuss the nervous system. So let's get started. First, before you begin our lecture series, make sure that you have done the VARK questionnaire. You can either use this QR code and scan it in, or just go to vark-learn.com and go to the questionnaire and then complete it. Remember, don't pay for anything, just answer all of the questions, read the instructions carefully, and then it's going to tell you a result of your learning preferences. So go ahead and do that. And then when you've finished, come back and rejoin. So I wonder what you found out. So it should have told you what numbers were your categories for V, visual, A, auditory, R, reading and writing, and K, kinesthetic. That's the action, that's the doing. And on the left-hand side of the screen, it should have told you, like, what are you good at? Are you good at 2 of them, 3 of them, or 4 of them, or just 1? Why is this important to know? Well, this is your learning preference. This tells you, how do you best learn? How do you like learning the best? Now, the more modalities you have, so the more of the V, A, R, and K you use simultaneously, the more likely you are to adapt to any kind of learning situation. Now, if you are an auditory listener and that's your number one thing, having a video and listening to a video would be a really good thing. So if you've got a book, listening to it as a book on tape whilst reading it, that's going to benefit you. Whereas if you are a visual learner, and you're listening to videos, putting on the subtitles, that's going to help you because you're reading at the same time. And same thing with read write, right? Looking at graphs, looking at pictures, that's going to stimulate. And kinesthetic, acting out ideas, being physical and doing, this is going to help you learn. So why is this important? Well, it's to do with how your brain works and to do with your nervous system. And it's going to be also very important when we're talking about the next subject, which is note taking. Okay, so make sure that when you're taking notes, you figure out what works best for you. Well, how do you know what works best for you? Well, as they say, practice makes, not perfect, but better. It makes you better, right? You keep practicing and you get better and better and better. So note-taking is an art form, and it took me years to figure out how best I took notes. And this was because I went through various different iterations of how to take notes. You might have done some of these. So there is the Cornell note-taking, or outlining, mind mapping. That was fun. The one that I kind of think is pretty awesome is sketch notes. You don't write much, you just draw. And some people think that this is a fascinating and incredible way of getting your brain to work. Well, my kind of note-taking is personalized, and it's kind of a combination of the outlining and the sketch noting. I'm going to show you how I take notes, and what I want to see is how you take notes. Try doing it my way and see if you like it, because again, practice makes better. You're not going to know until you try. So I wonder, have you actually tried and liked any other different kinds of note-taking? So let me explain my Pearman style notes. The first thing I do is I title my notes, right? Why? Because it now focuses my brain and says, this is what I'm going to be talking about. And it also helps so when I go back to look at my notes, I'm like, okay, we did it on brain, here it is. The second thing is I put a date, because a date is really important so I know when I did this. It helps with chronological ordering of my notes, and if a friend is absent and says, hey, I wasn't here last Tuesday, do you have the notes from class? What did we do? You can figure out what date Tuesday was and you can find it automatically, so it makes life easier. And then I go one step further, and if I'm handwriting my notes, I number my pages, particularly if it's loosely leaf paper in a binder. And I'm very glad that I did this, because one time in college, my binder broke and my papers went whee all over down the street. And once I picked them all up, because I had them labeled with both a date, a title, and page, I was able to put it all back together in my binder very quickly, a new binder that is not broken, and it made such a difference. Okay, so my style of writing notes is I am going to abbreviate or do drawings wherever and whenever I can. Okay, so if I've got a whole lot of information, I need to sit there and go, what was that? How can I put that in my own words, and how can I make it shorter? So that when I come back to look at my really brief notes and crazy drawings and arrows, I can then go, oh yes, this means this, and I speak it out and I can remember why I wrote this abbreviation. Now, if I had sat here and just gone, oh, there's a lecture, type, it goes in one finger and out the other finger, and it doesn't get processed by my brain. That is why I handwrite, and strongly recommend you handwrite everything. Scientifically proven that kinesthetic writing out your notes, makes a significant difference in your retention of information. Combine that with converting it into your own words and abbreviating and drawing. You're using different parts of your brain. You are far more likely to make it stick. And then if you jot it down later and talk it out, it becomes even more sticky and retentive. Oh, wow, right? We're trying to do everything we can to make this learning business easier, quicker, and more permanent. Okay, another fact, don't ever write anything down that you don't know about. So if there's a word that comes up and you're like, oh, I'll figure it out later, no, you figure it out now. So if it's in a lecture, put a star by it, go home and research the word. Don't ever, if you're reading a book and you're like, I don't know what this word means, and you copy it down, that's terrible, because you're still not going to know later, right? So always make sure that you know what you're writing and you know how it makes sense and how it interlinks with everything else. Good thing to do is to write yourself questions in the margin, or if you've got something that you're like, oh, that relates to that, and relates to this point of view, or I had an experience. The more that you can give yourself little notes and keep memory joggers, the better it is going to be for you and for your brain. After you've done all of your notes, go back and make sure that they make sense. Highlight the key points, underline them, make sure you've got them defined well, pull them out onto a note card so you can look at them later. Go back and just make sure that you've got the information and it all makes sense. And if it doesn't, then fill in the missing information. And finally, later that day, talk to a spoon. If you've got nobody else to talk to, if you've got nobody to tell about the amazing things you've learned, if you don't want to talk to yourself in the mirror, if you don't want to talk to a dog, a cat, or a stuffed toy, grab a spoon. Why? Because you're figuratively and literally spooning that information into your brain, and it's going to make it stick. I cannot stress it enough. Talk to a spoon. Okay, so what we're going to do today is that I have got a document from the National Geographic that explains about the structure of the brain. So this is kind of like you've got a textbook, you've got something you've got to read. So I'm going to show you how I would do it if I was reading a document or a chapter in the book. What would I do to take my notes? Okay, so let's get started. The first paragraph. Making sense of the brain's mind-boggling complexity isn't easy. What we do know is that it's the organ that makes us human, giving people the capacity for art, language, moral judgments, and rational thought. It's also responsible for individuals' personalities, memories, movements, and how we sense the world. Okay, sit back, think. Was there anything in this paragraph that I did not know? Or is there anything in this paragraph that I should make a note of? Not really, right? In my notes, I'm making sure I've got brain written down. Typically, the introductory paragraph is not always going to be really jam-packed full of information. So I can get away with making sure that I've got the title brain and that it's dated and that I'm ready to go in. It's keyed my mind into what I'm now talking about. Second paragraph. All of this comes from a jelly-like mass of fat and protein weighing about 3 pounds, 1.4 kilograms. It is, nevertheless, one of the body's biggest organs. Oh, not the biggest though. Think which was the biggest. Skin. Okay, that's my brain. Here we go. Going back. It is nevertheless one of the biggest organs, consisting of some 100 billion nerve cells that not only put together thoughts and highly coordinated physical actions, but regulate our unconscious body processes such as digestion and breathing. Okay, there was some key information in here. What was the key bits of information? Okay, we got fat and protein, 3 pounds, 100 billion nerve cells, and regulate our unconscious and conscious bodily processes. Okay, well, I'm going to make a note of that. This is literally my handwritten notes from a board that I did back in 2022. I wrote 3 pounds, 1.4 kg. Why did I write both? Okay, why did I put both of these down? Because it depends upon where I am and what literature I'm reading as to if it's going to be in pounds or kilograms. And this way I've kind of got an information of both I can compare it to. Okay, protein and fat equals brain. I'm not written any sentences here. I'm doing as minimal amount of information I can. Okay. Now I wrote under brain 100 bill nerve cells. Now that does not mean that every cell is called bill, right? It means that is short for billion. Okay. If I was to write million, I would write mil. If I was to write thousand, I would write K, because K represents thousand. Kilograms, K, 1,000 grams. Oh, right. So if I was 100,000, it would be 100K. Okay, cool. Now, I wrote here unconscious with a slash in it, because that says unconscious and conscious, that the brain is regulating, right? So if I reread this whole thing that I wrote, I could say, okay, the brain weighs 3 pounds or 1.4 kilograms and is made up of fat and protein, and there's 100 billion nerve cells inside it, and the brain itself is going to regulate all of the unconscious processes and the conscious processes. That whole blurb in very short, no full sentences, just minimal words and abbreviations where I can. Okay, let's keep going. Third paragraph. The brain's nerve cells are known as neurons, which make up the organ's so-called grey matter. The neurons transmit and gather electrochemical signals that are communicated via a network of millions of nerve fibers called dendrites and axons. These are the brain's white matter. Did you understand all of that? This is where I Googled, what is a neuron? And this is the picture of the neuron. So this talked about the dendrites and the axon, and we've got the axon terminal. Okay, but where's the grey and the white matter? What was it talking about with that? It was talking about this. It was saying, okay, that the cell body and the nucleus, the bit with the dendrite, that bit right there, that's going to be the grey matter, and the length of it is going to be the white matter. Okay, we got this. But then this is another image that came up. So if I type in grey matter and white matter, I can see that on this is what I'm looking at. So the outer perimetry is made up of the grey matter, and the white matter is more of the concentration in the middle. Okay, now I've got an understanding of what that whole paragraph was meaning, and now I'm going to put it into my own drawing. Now, do you remember the drawing that I showed you? Does my drawing look anything like that? The answer is no, and it's okay. I'm not offended. It doesn't. But does it still make sense to me? The answer is yes, right? You could draw something beautiful, but I drew that in about 3 seconds. It did not take me long to draw that. And there's a point to it, is because I want to be speedy, but drawing it makes me now use a part of my brain that says, okay, I'm now using these different portions. I'm more likely to remember it. Now, here's the deal. I went a step further because my brain went, oh, look at this information. I want to learn more. So I learned about neurons, and I wrote that this is my neuron. And what I can see here is, again, I've got this cell body, and I've got the nucleus, and that on it are the dendrites. They're like little fingers, right? So if this was the head, here's the cell body, these are the dendrites, and in the middle is going to be the nucleus, right? And then I've got a long shaft. This long shaft is the axon, and some of them are wrapped in this myelin sheath. Now, this myelin sheath acts like insulation, so it helps to keep the electrical signal that's traveling down this neuron going in the right direction, so it doesn't squirrel and go off into the wrong direction. If you've ever taken apart an electrical plug, right, on the inside of this electrical plug, there are going to be multiple wires. And inside each of those are going to be colored and wrapped in a particular plastic. Like on the movies, cut the blue wire, no, cut the red wire. Well, why are they blue and red? It's because they're covered in a plastic wrap to make sure that as the electricity goes down, it's going down, coming back. And it's not crossing in between the two. That's the same thing as this myelin sheath, right? It is insulating and making sure that it travels down the length of the axon, from the dendrites down the length to these axon terminals. So what you may notice down here in green is that I've done an E that stands for electron. This is the electrochemical signal that's generated from this cell, and it goes down the length, and then it hits these axon terminals, and it goes, where's my next spot? Well, it's down here. It's this secondary dendrite, right? The secondary neuron. But there is a gap. This is called the synapse, and this is really, really, really important. So this electrical signal gets built up, and then it gets to the axon terminal. It gets enough energy and goes whee, and jumps the gap and goes over to these dendrites, which pick it up and it travels down again. So this synapse is going to be an important point. This is the space between the two neurons that are going to allow for the signal to jump. Okay, we're going to come back to why that's important on pain management later. Okay. All right. Question, you still with me? How much does the brain weigh? All right. This is the fourth paragraph, so let's read it. The cerebrum is the largest part of the brain, accounting for 85% of the organ's weight. The distinctive, deeply wrinkled outer surface is the cerebral cortex, which consists of grey matter. Beneath this lies the white matter. It is the cerebrum that makes the human brain, and therefore humans so formidable. Whereas animals such as elephants, dolphins, and whales, they have larger brains. However, humans have the most developed cerebrum. It is packed to capacity inside our skull, enveloping the rest of the brain with deep folds, cleverly maximizing the cortex area. So, if I were to take a piece of paper, okay, and I was to put it in my skull, it would take up quite a bit of room. But if I were to take the same piece of paper and fold it like an accordion and keep folding it, do you see how much little space that takes up? But I have the same volume but a smaller surface area. So it is this folding that increases my brain. So that makes sense, right? So this is why it's cleverly maximizing the cortex area. So this is with the folds. Okay, well, let's talk more about that. Have you ever seen a mouse brain? It's pretty smooth. Human brains are much more wrinkly than that. Oh, look at that. How about these other brains, right? We've got various wrinkles. Well, ours is the most wrinkly, and that allows us to have this higher order thinking because we've got more of these neural connections that are allowing for more thought processes, right? So wrinkles increase the surface area. Now, we read a whole paragraph just now, so let's take a note. It said that the brain was made up of 3 parts. So I drew a little diagram. Does it look like a brain? Well, kind of. Not great, but it's okay. It doesn't have to be magic. It doesn't have to look like a Rembrandt. It doesn't have to look like this incredible painting, right? It just has to draw. So I drew this, whoop, bloop, bloop, right? And I put here the cerebrum, 85% by mass. Wrinkles, and I've done an up arrow, SA, increase, up arrow, neural cognition. So the wrinkles increase the surface area, which increases my neural cognition, which increases my brain capacity. Oh, okay. I also wrote something else. I wrote it up here in blue. I put Jiri are ridges and Sulci are valleys. And here you can see that we've got, again, this information that we've already talked about. The Jiri are the ridges, the Jiri, and the sulk down low in the valleys, Sulci, right? Why is this a sulcus and a gyrus? Because it's singular. Jiri and Sulci is plural. Okay, so I've done my drawing and I'm going to keep going. 5th paragraph. Oh, look, it's bolded. That must mean that they're important. Okay. The cerebrum has 2 halves or hemispheres. It is further divided into 4 regions or lobes in each hemisphere. So let me make sure I got that straight. The brain divided in half, 2 hemispheres. Each of these hemispheres have got 4 lobes. Okay, I got that. The frontal lobes, located behind the forehead, okay, so they're going to be in the front, are involved with speech, thought, learning, emotion, and movement. Whoa. Behind them are the parietal lobes, which process sensory information such as touch, temperature, and pain. Are you noticing that I'm using my hands? Kinesthetic learning here. I'm trying to make sure that I'm understanding, right? So frontal lobes, parietal lobes, okay. At the rear of the brain are the occipital lobes that deal with vision, okay. And then on there, lastly, there are the temporal lobes near the temples, which are involved with hearing and memory. Oh, okay. So now I understand. I've got to deal with these main terms: hemispheres, lobes, frontal, parietal, occipital, temporal. Okay. So guess what I did? I drew a picture. Now, it's not a great picture, but it works. Okay, so I drew a picture, this one right here, and I divided it up with a line straight down the middle. And I put here half of the cerebrum equals a hemisphere, and then 4 lobes. All right. And then I labeled them. I put frontal, parietal, occipital, and temporal on the side. Now, in this, I drew little pictures. Now, I don't know if you can tell what my pictures are, but I know what they are. This here is a speech bubble or a thought bubble, because the frontal lobe, and I wrote it out here because it was so important, it's for emotion, it's for learning, for thought, for speech, and for movement. Now, the parietal lobe, okay, so this here, this little squiggly thing, that's actually a hand because it's for touch. This was a thermometer because of temperature, and this is a dude going, ah, because that's for pain. And because later in the years I might come back and go, what did I draw? I added a little note: temp, touch, pain. Okay, so that's a parietal. Now on the sides, any idea what that squiggle is? It's an ear. And I know what that is because I drew it. And there's some music. So I've got temporal for memory and for hearing. And then in the back, that is not a weirdness. That is an eyeball. And that's occipital for vision. Okay. Now, do you notice I've got posterior and anterior? I've got my positions in place. Okay, cool. If I was really struggling with my drawings, I might want to have a look and see a better picture. And yes, I could draw it a little better than this. I could color coordinate it, but I kind of like my drawing. Okay. All right. Cool. We're going to keep going. So we looked at the frontal lobe. Okay, we looked at the frontal lobe, and this is probably the most important lobe in terms of personality, learning, emotion. This is what makes you you. Okay, this gives you all of you. Now, did you realize that there is a stress hormone called cortisol? Now, when you're stressed, it likes to bathe this frontal lobe and shut it down, because you don't want to be thinking about, well, should I run? Should I not? There's a tiger chasing me. I need to run, right? So the frontal lobe shuts down all of logic, all of thought, all of reasoning, right? When you're in a stressful situation, such as being chased by a tiger or a lion or a bear, oh my, right? So, but the back of the brain, this is the part that comes on, and it's the survival part of the brain. The midbrain, the back of the brain, it's survival. It's like run, 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 hide. And that if you then fall over and trip and you hurt yourself and you get pain, well, you're not thinking about it. You're thinking about running, right? Because you're trying to get away from these lions and tigers and bears. Oh my. But, right, our body doesn't recognize the difference between taking a test and being chased by a tiger. Stress is stress. And our body produces this cortisol and it shuts down our frontal lobe. So you may have gone on a test and you're like, I remember all of this information. I know I studied it. You get to the test and your mind goes blank. Why? Because that stress hormone covers your frontal lobe. This cortisol shuts it down, and all of that learning and thoughts, they've gone bye-bye. But there is an antidote. You'll be pleased to know, and it's real easy. It is free. It is oxygen. The only way that you can counteract the poison of cortisol, which is useful if you're being chased by a tiger, not so useful if you're trying to take a test, is by taking some deep breaths. Oxygen. Nice, slow, deep breaths. Get that oxygen level up again. And you will notice that your learning and your thoughts and your memories will come back online and you'll be able to think clearer again. Amazing! Okay? Not difficult, just breathe. All right, we're going to make a connection to literature right now. Who'd have thunk it? Have you read the book, or will you read the book, One Flew Over the Cuckoo's Nest? It's an excellent book, a good movie, and in it, the lead character, Randall McMurphy, he is in this ward, and he is not being compliant, and he is being problematic, and so he gets a lobotomy. Now, a lobotomy in the old days, they've been doing this for a long time, medieval time. They would take a hot poker out of the fire and shove it up somebody's nose and put it into their brain and start to scramble their frontal lobe. They can do it up the nose or even through the eye socket, and they can just remove part of this frontal lobe. Remember, the frontal lobe is for emotion, for learning, for speech, for thought. So if you've got somebody who is psychiatrically non-stable, or that is schizophrenic, or that is combative and aggressive, if you are damaging this frontal lobe, they then become compliant. Unfortunately, they did this a lot in the old days. Not so much now. They don't tend to do very many lobotomies. It's still available, but they don't tend to do it now very much. So this is removing part of the frontal lobe, and they don't do it with a hot poker up the nose. They do it surgically, very clean, sterile. But in the old days, that's what they used to do with patients that they thought had too much aggression, or were schizophrenic, or had bipolar disorder. They would get a lobotomy. And this is what happened in One Flew Over the Cuckoo's Nest. So when you read it, or if you've read it, you now can make that connection and understand. Okay, let's go back to my document. Okay, 6th paragraph about movement and balance. Okay, so now I'm thinking about that. The second largest part of the brain is called the cerebellum, which sits beneath the back of the cerebrum and is responsible for coordinating muscle movement, controlling our balance. Consisting of both grey and white matter, we know what that's about, the cerebellum transmits information to the spinal cord and other parts of the brain. Okay, well that makes sense. So now, let's go back to my drawing here. And you will see, can you tell I've done this a few times? This is one from the whiteboard and this is one from my e-glass. Anyway, so the cerebellum, and it says practically the same thing. It is for balance and movement, involuntary muscles, and is called the little brain. And it's a relay station. Okay, so the back of the brain helps with your involuntary process of muscle movements and with balance and all sorts of good stuff. Okay, so that's what I added to my drawing, and I recommend you add it to yours. Notice the structure and the shape. Okay, cool. It's a C shape because we're bipedal. Okay, cool. Okay. Oh, do you remember what part of the brain is cut or destroyed in a lobotomy? All right, here we go. 7th paragraph. The brainstem at the organ's base controls reflexes, crucial basic life functions such as heart rate, breathing, and blood pressure. It also regulates when you're sleepy or awake. Ooh, your circadian rhythm. Okay, so what did I put on my notes here? I put brainstem, heart rate, breathing, Z, 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 Z. Why? Because Z's were easier than writing sleep-wake cycle. Just was. And now I know, oh yeah, when I see those Z's, I know what it means because it's now going to trigger my brain saying, oh yes, this was a sleep-wake cycle. Okay, so we've got here, right, the brain, important, life forces, very, very important, this back of the brain. Again, this was the part of the brain that we need for survival. The frontal part, learning and thought, not so much. We need it for us as personality. The back of the brain, this brain stem and the cerebellum, this is going to be for survival. Okay. Keep going. 8th paragraph. The brain is extremely sensitive and delicate, and so requires maximum protection. This is provided by the surrounding skull and 3 tough membranes called meninges. The space between these membranes are filled with fluid that cushions the brain and keeps it from being damaged by contact with the inside of the skull. Cool. Okay, well, let's write a paragraph, this paragraph in my notes. I wrote protection, the 3 things. Have I already said that there's a lot of stuff in science that comes up in 3 things? If not, there are a lot of stuff in science that comes up, particularly in anatomy physiology, that are 3 things. We've got 3 levels of protection: the skull, the meninges, and the cerebral spinal fluid. Of those meninges, we have 3 different membranes: the dura mater, the arachnoid mater, and the pia mater. And the purpose of the cerebrospinal fluid, which sounds like it's made up of 3 parts of a word, is 3 things: cushioning, cooling, and circulating. The 3 again. All right, so let's go back to our skull. Can you poke your brain? Nope, we can't poke it because there's a nice skull in the way. But did you know that in the beginning your skull was not fused? It was not fully developed because right before birth and during birth, those bones are going to be able to go to make it so that it can fit through the vaginal canal and fit through the birth canal. So the skull actually has a soft spot for babies. Right here, it's called the fontanelle. That's why you should never touch a baby on the top of their head. It takes a couple of years for it to fuse fully. So at birth, you have about 270 bones, but by the time you are an adult, you have about 206, 213 bones, and it varies from person to person based upon genetic anomalies and variations in the type of the bones and the fusing. But the skull itself, right, is there for protection, but it doesn't fully protect until a couple of years later. So what's stopping you on a baby when you shouldn't, right, to touch and squidge the brain? That is because of the meninges. We'll talk about those in a minute. Now, this hard casing, awesome for protection, but not so awesome if you're going to have some damage. Do you remember that foramen magnum? That was that hole where the brain stem attaches to the spinal cord and allows for, the connection of the head and the brain. Okay. If you hit your elbow on a table, ow, my elbow, it's going to swell up. If you hit your brain, it's going to swell up because that's what it does. It's a swelling mechanism. But your elbow could get really quite big, or your wrist, or wherever you've hit, right? It can get quite big because there's nothing surrounding it. But that poor brain, look at it. It is encased in this hard bone. And if it swells, where's it going to go? Well, it's the only place it can go. It is going to go down that foramen magnum. Row. That could be problematic. Why would that be problematic? Well, it's because what is being squished? The brain stem and the potentially the cerebellum, which means your vital life functions. Ooh, we're going to talk more about this in a minute, but just wanted you to see it. This is all enclosed except for that one spot. Okay, so let's talk now about the cerebrospinal fluid. Okay, so the cerebrospinal fluid is produced. Oh gosh, that's a lot of writing, isn't it? It's produced 500 milliliters a day, and then replaced every 7.5 hours. So basically, we're producing it and we're absorbing it at the same rate. Let's have a picture. All right, so in the middle of the brain, there is actually a hole called the lateral ventricle, and inside here are some cells that are going to make the cerebrospinal fluid. It then goes and travels down around the brain, down the brain stem, up and back and around, and then it gets reabsorbed by the surface of the brain. Pretty cool, really. So we're making and absorbing at the same time, and it's traveling all the way around the spinal column, back up to the brain and back around and back down and up and around and down and blah, 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 blah. So we got circulation. It's also there to help with cooling, and it's also there to help with cushioning. Which brings us to a concussion. Hopefully you've never had one and never will get one, but a concussion is whereby you hit your head and your brain slams into the skull. And just like I said, if it slams into like you slam a body part, it can swell up, and that's the same thing with your brain. If it hits the inside of the skull, it can get damaged. You can actually shear and break off the neurons. You can have shifting between the grey and the white matter. You can have significant trauma of the brain if you get a concussion or damage, right? So as I said, where does this swelling go? Well, it's going to go down that foramen magnum. But if it goes down the foramen magnum, remember that brain stem and the cerebellum is for vital life functions. So it's going to crush your breathing. It's going to crush your heart and your pulse and your blood pressure. And it's going to stop involuntary muscle movements, which is why they shine a light in your eyes. If your pupils react equal and reactivity, it is showing that those muscles that are controlling the iris are reacting fine. But if one's sluggish or doesn't react to that light properly, it's indicative that there could be some swelling and damage to the brain because it's crushing down on that brain stem. That's a problem, right? So instead of it crushing that region, they can actually make burr holes. What? They removed sections of your skull to let your brain swell up and out those holes that they make, rather than crushing the vital life functions and causing you to have, potentially die. So they can actually make burr holes. Now, I have a question for you. How long do you think they've been doing this? The answer is a very, very long time. Instead of it being called burr holes, they've been doing trepanning, which is where they drill holes in the skull. They've been doing this since cavemen, like in prehistoric times. They used to get a flint or a rock or a stone, and they would, there was no anesthetic. They would hold Ugg down, you hold Ugg down. Why would they do this? Because they thought that maybe epilepsy or seizures or migraines or even schizophrenia and bipolar disorder and stuff were caused by trapped evil spirits inside their skull. And so they would, how did they not die from this? Well, a lot of them did. But we actually have fossil evidence whereby we've got these skulls with holes in them with new bone growth over the top that showed that not only did they survive, but they actually healed. Whoa, crazy. So this trepanning is where they drill a hole in the skull. It was actually touted as a way to get rid of lewd thoughts. Like in the early American developments, like you would have traveling snake oil salesman that would say, this is going to cure your X, Y, and Z. And really it was just horse urine, and it had no medicinal properties, and they would sell it, they would buy it, and everybody would go with the placebo effect. We're like, I'm cured. And then the salesman would leave, and then they wouldn't be cured because it was just colored water or horse urine, right? And same thing here with the trepanning. Yeah, probably not going to banish any lewd thoughts. Painful, but effective. No, not really effective at all. And it would probably have lots of cross-contamination and rust and but by the time that the illness hit, the salesman that did this is gone. Oof. Now, let's go back to our protection, all right? So we've got the cerebrospinal fluid. It is there to help with cushioning so that it will prevent you from getting a concussion. But obviously, if it's strong enough blow, no matter how much liquid you got in there to prevent it from shifting, it could actually cause problems. Now, the brain is also going to need a huge amount of cooling because it's working. Yes, we sweat and everything comes from there, but also that circulating cerebrospinal fluid helps to maintain the body temperature so we don't denature the proteins. Do you remember that word? I do hope so. Denature, where that protein changes. Anatomy dictates physiology. Oh, we're piecing it all together. And circulating. So again, any of the nutrients and stuff, it can circulate through the brain, around the brain, and down the brain stem. Let's talk meninges. Meninges are the membranes that go around the surface of the brain. There are 3 of them. The dura mater is the closest to the skull, and it's really thick, and it translates literally into tough mother. It looks like a swimming cap. This is a real human brain, and that's the dura mater you can see. It does look like a swimming cap, doesn't it? All right. Just below the dura mater is the arachnoid mater. It looks spider web-like. And again, arachnoid mater, spider mother, arachnoid. Okay. Pia mater is the one that's on the surface of the brain. Now, when we look at the surface of the brain, it looks like saran wrap and is over the surface. And that's the pia mater, and it means tender mother. If you actually look here at this part of the skull's been removed, and you look here, do you notice that there is space between the brain, the dura mater, and the bone? Well, in an actual living brain, that wouldn't, head, that would be filled with the cerebrospinal fluid, okay? So inside, outside, and around. And again, dura mater, tough mother, arachnoid mater, tender mother, and pia mater. No, arachnoid mater is the spider mother, and pia mater is the tender mother. Okay, we got it. Now, this is one that we need to talk about because meningitis, you should be getting a vaccination if you go off to college against meningitis, because unfortunately, this is a really, really, really nasty process that can kill a lot of people very quickly if you're not vaccinated, and it can run through college campuses really rampantly. So we want to make sure that I want to make sure that you understand what meningitis is. So meningitis, let's first break down this word. Itis, inflammation of the meninges inside the brain, right? So the layers. So meningitis, right? The symptoms are you get a fever, you're kind of sleepy, you got a headache, you don't like the light, you might be vomiting, you might be sore, you have a rash, and you could in some cases have seizures. Now, okay, so let's look at these a second. You get a headache, you got light sensitivity, you might be vomiting. You might also have some joint pain. Could you also get all of these symptoms if maybe you've got a hangover and you fell asleep on the floor in an awkward position? Yeah, but it's not a hangover, right? If you got these symptoms plus you're like no light and you get this rash, okay? It's really, really important that you understand about this rash. If you put a glass over the surface of a rash from meningitis, it does not fade under pressure. It doesn't change color. So if you've got these telltale signs of the light sensitivity, the pain in your joints, the nausea, the vomiting, the headache, the light sensitivity, and this rash that doesn't change, please immediately go to call up the clinic and say, hey, these are this. They're probably going to send you to the emergency room because they need to figure out immediately what is causing this infection. So they need to know whether or not it is a viral meningitis or bacterial meningitis, because if you've got bacterial meningitis, they can provide you antibiotics. But if it's viral meningitis and they provide you antibiotics, it ain't going to do a thing, right? Because you need antiviral medications and vice versa. Antiviral isn't going to help bacterial. So how are they going to tell in your brain what you got? Instead of doing open brain surgery, which nobody wants, right? They're going to actually do something very clever. It's called a lumbar puncture. This lumbar puncture, they are going to anesthetize your back. So they give you a local injection and they are going to put quite a large needle into the space in between your vertebrae. And this will access the cerebral spinal fluid, and they collect it into a little vial like you see in this drawing right below me, or photograph below me, and they can then send the cerebral spinal fluid off to the lab and they can analyze it for what is causing you to get sick. So you don't have to actually access the brain to figure out what's wrong with the brain. You can actually access the fluid from your spine. Okay, so hopefully you're sitting up nice and straight. Run your hand down your spine, down your vertebral column, and you can feel how all of your vertebrae are kind of aligned. Now get to a spot where you can bend over and rub your hands along your spine, and you can feel how there's now a space that's opened up in between your vertebrae. And that's why you lie on your side, bring your knees to your chest, or you're sitting on the side of the bed, probably not for this because you're pretty sick, but they do this for other things. And you bend over and hug a pillow, and it opens up the space so they can get the needle in to get to the cerebral spinal fluid, which is really pretty clever. Okay. So if you've got the symptoms, make sure that you get it fixed because it is a deadly disease and it really horrible. So treatment is immediate, right? You got to get fixed. Okay. Most people now are getting a vaccine for it, so yippee for vaccinations and protection. Okay, let's keep going. Now, let's have a looky-loo at these brain images. Now, as somebody who's got Alzheimer's, if you look at these bottom images here, this brain here looks very different than a normal person, a normal elderly person versus an elderly person with Alzheimer's. What is the difference? Well, if you look here, there is some significant brain loss. Those wrinkles are not really wrinkly anymore. They've got big crevices, and you can see how the brain itself has been eaten away by this disease. This is a progressive debilitating disease where it is eating away at the brain tissue. Neurodegenerative, that's the word I was looking for. That's pretty bad, right? Okay, the next one's really shocking. This is an alcoholic's brain. Can you see the difference? Somebody that's an alcoholic, its brain is being eaten away as significantly or worse than somebody with Alzheimer's. Now, this is not if you've had a drink at a wedding and this is somebody who's a severe alcoholic, right? But it doesn't take excessive amounts of alcohol to get to that point. And as we're going to find out soon, our brain chemistry changes and makes it more likely for addiction to occur the younger we are starting these addictive processes, which is why it's really important that we don't indulge in drinking as teenagers, and certainly not until we're of legal age. Why is the legal age 21? Well, partly it's because our frontal lobes that make our rational decisions is not fully formed and functioning until we are ladies 25, gentlemen 28. So if we've got a half-developed frontal lobe and we add alcohol, which suppresses this frontal lobe anyway, we're more likely to make irrational and silly choices. That's a problem. And secondly, our liver is not actually primed and ready to make the enzymes to fully break down the alcohol until we're about 25, which means that our liver is getting damaged by us drinking at a younger age. Our brain is getting damaged and more likely to carry on addictive traits as we go along through life. Let's look at this again, some more images, right? Alzheimer brain, and let's look at an alcoholic brain. Oh dear. So why is it important that our brain stays nice and healthy and wrinkly? Because it allows us to have these neural connections which allow us to have the good thought and functioning of our brain. Okay. Question. See if you're with me still. What meninges, which meninge, it literally translates to tender mother. Okay. So this was my entirety of my notes. This was what my board looked like, my notes looked like from doing my document. And this was the document. These are screenshots of the document. So you can see there was a lot of writing that I did not include in my drawing. Okay. Time for a brain break. Here we go.
Now we're going to work on our mental health with a focus activity called Pinky Thumb. What you're going to do is open your hands up like this. Make sure your palms are facing you.
Make sure you're doing this.
Close them into fist. We're going to put one thumb out on one hand, one pinky out on the other. And when I count to 3, we're going to switch. 1, 2, 3. Switch. Let's try again. 1, 2, 3. Switch. Now, some of you at home may be wondering, wow, this is more challenging than I expected. Yeah. But guess what? Our brain loves challenges. And I want to break down what's happening in our brain as to why this activity is sort of challenging. So everybody put your fists like this, put them close together. This is about the size of your brain. And the way your brain works is that one half of your brain controls the opposite side of your body, which means the other half controls the other side. When we do 2 different things at the same time on each side of our body, we're working both halves of our brain. Our brain loves this. So that's why we incorporate these exercises. These are called neuroplasticity exercises. So let's try it one more time, but we'll break it down. Thumb out, pinky out, thumb in, pinky in. Thumb out, pinky out, thumb in, pinky in. As we get better, we'll go back to both out, both in, both out, both in, both out, both in, both out, both in. Great job. Keep practicing. Don't give up. I promise you'll get better and better as you keep going.
Practice makes better. Awesome. That was fun. I enjoyed that. How did you do? I hope you did well.
Now,
all right, so here's the dealio. All right, your brain, it needs keys. It needs you to key it in for when it's time to learn. All right, so one of the best things you can do is be early, right? I've got a early to class, early to be ready, so that you got a moment to breathe, to get you sorted and get focused, and rather than rushing in last minute. Not good. I have a little saying, early is on time is late, and late is unacceptable. If you keep that to your heart and keep to live by that, you are going to be more successful, okay? Don't put things off for tomorrow that you can do today. Get it done, right? So on and so forth. Next thing that I will say that helps key the brain in for studying and making sure that it's going to learn is, your posture and what you wear. Okay. So if you're all slunched over and you're like in bed, are you going to be ready to, study? No! Get sat upright. Be in a place where this is work. We're doing this. We're focused. We've got our focus hat on. And it keys your brain into this is work, because this is what's going to happen. If you try and study in bed, you are going to confuse your brain. And when you try to go to sleep, your brain's like, is it sleep time? Is it study time? What are we doing? I don't know. And so now you're going to lay there awake. Whereas if you're trying to study in bed, your brain is like, I'm tired. I don't want to do this. And you're going to go to sleep and you're not going to study as well. So it's really important that you give yourself the best chance. Key your brain in. So dress. Why does that matter? Dress for success. Now I've got a question. Would you wear your pajamas to prom? Would you wear your prom dress to a sleepover? No. Would you wear sweats to a job interview? No. Why not? Because what we wear helps us to feel the part. So if you're wearing pajamas and you're trying to study, guess what? Same things your brain's doing. Pajamas mean sleep. I'm not focused. But if you dress for success, then you're actually going to key your brain into being much better. Whoa. And again, starting to know how to do your notes, start it off right, putting the title and the date, it keys your brain into saying, okay, this is us, we're going to start to study. And you can actually help it by doing some pre-work, like, what are we studying today? Know what we're doing. Don't come in blind, right? Know what you're going to do. It helps your brain to be ready to receive that information. So how can you know what you're meant to know? Well, I've tried to help you. On my bulletin board on the right hand side, there is a link, and on it says overview and key points. Key points. Now, when you click on that, you're going to bring up a Google Slides presentation, and this is the HSB overview and key points for each lesson. Always keep in mind, though, that this course, you need to think about the anatomy, the structure, the physiology, the function. We've been talking about health, and ask yourself why. Every time, why does it do this? And if you can't answer why, then you need to go back and you fill in the details. So, for example, each of our lessons is broken down and it gives you the key points. So let's look at this one. What is this one about? We talked about the 3 parts. We talked about nerve cells. We talked about protection. We talked about ailments, and voila. That's keyed my brain in. I know what the main facts are, so that if I had read this before the lesson, when I got to talking about meningitis, my brain was like, oh, I remember that was something we were meant to key ourselves in on. Oh, but you know what our brain also doesn't like? It doesn't like having distractions. It doesn't like having all of these extra things pinging and ponging and moom-ba-doo-ba-doo-ba-doo. When you're trying to study, guess what? Your brain cannot do 2 things at once. It cannot manage to do 2 things at once well, let's put it that way. And your brain can become overly stressed, and what's going to happen? That frontal lobe's going to shut down. So guess what? You got to get rid of the distractions. If you're going to study, put that phone away. Put it in another room. Put the do not disturb on your computer. Don't have it so that you're disturbed, because otherwise your brain is like, you can't do it all. Help me, help you. That is your brain saying, help me. Key in on the focus on the good stuff and get rid of all of the distractions so I can help you to learn it. Learn it right the first time, and you don't have to keep studying, right? Your brain cannot do 2 things at once, and they certainly can't do it well, 2 things at once. For example, do you remember we talked about hiccups, diaphragmatic spasms? Well, your brain cannot do 2 things at once. So your brain has gone into like, oh, what? I love it when kids get hiccups in my class. Do you know why? Because I can cure it each and every time. I'm the queen of curing hiccups, because I will make you do the weirdest things. You're going to walk a line forwards and backwards, humming a different song. You are going to talk about the colors of the rainbow whilst doing it backwards, singing the ABCs to the Star Spangled Banner. You are going to be touching your nose and do it. Like, I will make you do weird things, and all of a sudden your brain is like, oh, we're being tasked to do this, and it forgets about the hiccups, and then guess what? Your hiccups are gone. Because it automatically resets your brain, because your brain cannot do 2 things at once. Not well. Certainly not well. Question. What's your go-to move when you have the hiccups? How do you get rid of them? Right? I'd like to know. Okay, so I'm going to show you something. All right, so we're going to read a passage. It's going to be really interesting. We're going to read a passage, and I'm going to show you how your brain studies, right? Okay, so are you ready? There's going to be a quiz at the end of this, so make sure you read this well. Okay, here we go. So read the following passage. The mice. Mice live in our walls, but do not trouble our kitchen. We're mice. Oh, wait. Do you remember that there was a really cute movie that had mice in it? Do you remember? And his name was Gus Gus. I liked him, and he would sing, Cinderella, Cinderella. Oh, wait, sorry. I was reading a passage. Right, let me go back. Okay. So, mice live in our walls, but do not trouble our kitchen. We are pleased, but we cannot understand why they do not come into our kitchen. Ooh. Oh, well, Amy said that she didn't really like Riley, and Riley got mad, and she said that she's dating Joey because their drama. I was reading. Oh my gosh, I've got to go back. Okay, where was I? We are pleased we cannot understand why they don't come in the kitchen where we set traps as they come into our kitchens of our neighbours. Although we are pleased, we are also upset because the mice behave. Oh, ping! Felicity just posted I'm not going to look. Okay, we're reading this. Okay, but they're really cute. All right, quick look. Oh my goodness. That looks too funny. All right, where was I? Let's see. Although we're pleased, we're also upset. Haven't I read this before? Because the mice behave as though there was something wrong with our kitchen, which makes us even more puzzling in this house. Oh, that dog was so cute. No, the house is much less tidy than the houses of our neighbors. No, I'm not. No, Jack, no. Okay, reading. There is more food lying about in our house, more crumbs on the counters, and filthy scraps of onion kicked. Jack's still typing. Oh my gosh, this is better be good. Right. No, I'm reading. So Jack, no, not Jack. The onion, where was I? Filthy scraps of onion kicked against the base of the cabinets. In fact, there is so much loose food in the kitchen. I can only think the mice themselves are defeated by it. Jack's still typing? What? Okay, no, I'm okay. So they're defeated by what? The loose food. So much. Okay. So in a tidy kitchen, it's a challenge for them to find enough food night after night to survive until the... Oh, my phone is blowing up. There must be something good going. No, I'm reading this passage. Okay. So night after night to survive until spring. Patiently hunt and nibble hour after hour until they're satisfied. Oh my gosh, the quiz is about to start. In our kitchen, however, they're faced with something so out of proportion that experience cannot deal with. They might venture out a few steps, but soon overwhelming sights and smells drive them back into their holes, uncomfortable, embarrassed, not being able to scavenge as they should. Oh, quiz time. Where are the mice? Name 2 locations. What food scrap is specifically mentioned? Oh, wait, I know this one. Do you know this one? Why is the tidy kitchen a problem for the mice? I could guess. Do I know it? I don't know. Why is the author's kitchen a problem for the mice? Oh, I know. Okay, yep. Did you know? How do the mice feel in the author's kitchen? And how does the author feel about the mice not being in the kitchen? Wasn't there mixed feelings? I'm not sure. All right, well, had this been a real quiz, honestly, how well would you have done? We can go back and reread the passage if we want to. You could pause it now and then go back and answer the questions and see how well you actually did. But I got a question of the distractions. Who sent you a message? Oh yeah, I bet you know. What was one thing you saw in the dog video? I can think of a lot. What else do you remember about the distractions? There were a few, right? What was the name of a mouse? Didn't I say something about Gus Gus? Did the mouse in the story have a name? Oh wait, was that the mouse in the story? Or was that my brain fart going on about Cinderella? Alright, well, how did the distractions make you feel? Well, they did not make me feel good. No, they didn't. I did not feel good about those distractions. They frustrated me, and I don't feel like I read anything and understood anything in that passage. No. So I'm going to say this again. Help your brain help you. Put the distractions away. That means your phone. Put your phone away. Put away any distractions you can possibly find. Put them away because it is time to study. Now, if this means pausing, making amends, going and putting your phone away, go do it now. Get up, have a stretch break, because when we get back and we're going to talk about the next thing, we're going to talk about brain chemistry and addiction. Okay, hopefully you're with me with a clean slate. Here we go. Let's talk about neurotransmitters. Neurotransmitters are chemicals that neurons use to communicate across the gap between them, known as the synapse. Remember, I told you there was going to be something about that synapse. So we're sending a signal from one of those axon terminals, and it releases a chemical, a neurotransmitter, boop, that then goes across that gap and gets picked up by the dendrites of the other. So the axon terminal to the dendrites of the next, and it jumps that gap of the synapse, okay? When it reaches the end of the neuron, it triggers the release of a neurotransmitter which binds to the receptors of the next neuron. Okay. We've got some key neurotransmitters. So this would be in your notes now. I'm leaving you to take your own notes now. I want you to practice my style of notes. So what do you think you should be drawing? What do you think you should be writing down? Okay, so we've got dopamine. This is links to pleasure and reward. Serotonin affects our mood and our anxiety. And adrenaline, that fight or flight, right? The balance of these chemicals is crucial for normal brain function. So we need these for our brain to function. But unfortunately, they can be affected by various factors such as drugs and stress. Okay. So let's define addiction. Addiction is a disease. This is very important for you to understand. Addiction is a disease. This is whereby you have a progressive narrowing of things that give you pleasure. I want you to make sure you have that key point written down in your notes. Addiction is the progressive narrowing of things that give you pleasure. So if I said to you, or if I said to my kids, guess what, guys? We're gonna go to Disney, the happiest place on the earth. Do you know what my kids or I would have done? You'd be so excited. I would go to Disney. I would love it, and 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 it would be amazing, and I would have such a good time, and I'm so excited about going to Disney. Oh, but if I said, okay, well, we're going again tomorrow. Yay! We're going again tomorrow. We're going again tomorrow. We're going to do the same exact ride, same and same again. Okay, we're going to ride Splash Mountain. We're going to ride It's a Small World. It's a small world after all. And we're going to ride it again and again and again. And a week later, that's all we're doing is we're riding It's a Small World, going around and around and around. And I'd be like, blah, 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 blah. Okay, well, then I say, okay, we're going to go again. We're going to go back to Disney. And I'm going to be like, yippee. But then if I say, okay, well, this is it. We're going to go back and we're going to go on It's a Small World and we're going to ride it 17 times in a row. No, right? This was the happiest place on earth. But because I have done the same thing over and over and over again, the pleasure of it narrows and now it's just like, no. This is the same thing that happens with addiction. This is the same thing that happens to our brain. And it's all in this limbic system of the brain. Okay, so this is the part of the brain that generates a whole lot of hormones and chemicals that regulate the processes of the brain. This part here is the survival mechanism. And one of the things we have to realize is that sometimes addiction can be good. For example, when a baby is first born, it gets put to the breast immediately, or it's given a bottle immediately, and it is told to feed. And it releases dopamine that rewards it, and it gets addicted to food. Without doing this, the baby wouldn't eat, and that womb would die. So that would be a bad thing. But when we get things like alcohol dependencies, addiction to sugar, to gaming, to internet scrolling, to drugs, to Facebook likes, to gambling, to so on and so forth and so on and so forth, this is when it becomes bad. And the reason is because of this dopamine reward system, okay? So we need dopamine to actually provide us with a reward for doing something good. For example, if you've got a list of things to do, like take the syllabus, for example, every time you do something, you cross off that to-do item, it releases a little bit of dopamine, a reward, and it says, that was great, do it again. That's awesome, right? It provides us joy and satisfaction and provides us motivation to keep doing the same thing, okay? This is a good thing. But it becomes a problem if we then connect it with bad behavior that then causes us to have this narrowing of things that gave us pleasure before. Okay. Quick question. Why do we want to release dopamine? So as more dopamine is released, the level of dopamine pathways are adjusted and it sets the threshold higher. So again, that narrowing of focus. They've actually been able to measure how much dopamine is released within our blood. And it of like conditions of what's happening. So they've measured it. On a normal day, we have about 50 nanograms per deciliter of dopamine. That's on a normal day, just ho-hum normal day going about my business. Now on the worst day ever, I've caught every red light, I've got a flat tire, I got pulled over, I've got food poisoning. It's a horrible day, like really bad, no good, horrible, awful day, right? This is the dopamine level drops to 40. Okay, not too low, but it's 40. It's a really bad day. Now, on the best day ever, I've got every green light. I got an A+ on my paper. I been complimented on my, I don't know, whatever. It's an awesome day. The sun's shining. I've done my favorite activities. I've gone to the beach. I found a beautiful shell. I'm as happy as can be. Best day ever. I've won the lottery. Not that I ever play, but you know, I'm had a fabulous day. And my dopamine level goes up to 100. Well, that's cool. All right, I've got a good, it's a good day. Good boost. Make me feel great. Give me joy. Now, here's the deal. When I indulge in abusive substances that are addictive, such as opiates, alcohol, gambling, where I get a reward, like these sorts of things, methamphetamine, these addictive substances, unfortunately, it provides way too much dopamine. And by way too much dopamine, if you indulge in methamphetamine, it releases not 100, but 1,100 nanograms per deciliter. The amount of dopamine is sky high crazy, right? That's a problem. Our brain is not designed to have that much dopamine. And so the brain's like, whoa, okay, well, we'll reset to this amount. Now, all of the things that were previously causing us joy, all of the things like family vacation, this level here, right? Do you see how awesome it is? Well, the best day no longer means that we're happy. Right? This is the new level, the new threshold for joy, for happy, for the best day. Nothing comes close. So people that were addicts, they no longer find joy in the things that they used to. So if, let's say, they used to play guitar and they found much joy in playing music. Nope. If they're an addict to, let's say, methamphetamine, cocaine, alcohol, this no longer fills them with any sense of joy because it's their body has reset that threshold to too high of a level. Now, when they take this drug, the first time they take the drug, they get 1,100. The second time they take the drug, maybe 900. The third time, 600. They're never making it to that 1,100 again, that euphoric level. And so they're now starting to, if they take the drug and they're taking it and taking it and taking it, they're taking it just to maintain the best day, or they're maintaining a normal day, and even to the point where they're now down to really low levels. They have to take this drug in order to prevent the withdrawal symptoms, to prevent these negative things. If they don't take it, they're now hook, line, and sinker having to take this drug just to make it so that they're normal. So this is why this lack of dopamine, because it's not meeting that threshold, causes the craving and the desire and the need to get this. It's so primal, it's going back to that middle of the brain, that it is saying you must have this. It's like stronger than breathing. It is an absolute urge that you have to have this. That's why people might go and sell grandma's jewelry to get money to buy the drugs. Well, you wouldn't ever think that they would do that because that's just horrendous. But it's that primal urge that is making them do this, to get to survive, to get the drug or the addiction or whatever it might be. Now, they did a study which was really pretty cool, and they dehydrated people. Basically, they stopped them from having any water, and they did this for 3 days. And they're at the point of dehydration where they're becoming really, survival mode is kicking in, okay? And they put them in an MRI machine where they looked at functional MRI, and they looked at the functionality of their brain. And they lit up the inner portion of the brain and the activity they measured. And they said that it was a relative size of a baseball, a little bit, right? So that's the relative amount of activity that was occurring. Now, they did the same thing, but they did it with starvation. They stopped these people from eating for 5 days. And when they put them in the functional MRI, they asked them to explain their favorite food. They asked them to smell their favorite food. They wafted it into the tube. Eat their food, but spit it out. They weren't allowed to have it. And their starvation mode kicked in, and their brain activity lit up relatively to the size of a basketball. Now, they took people with addiction, whether it was alcohol or methamphetamine, cocaine, whatever drug of their choice, and they put them in the fMRI, and they looked at their brain's activity and relative size. They did this for people that were 30 days out sober, 60 days sober, 90 days sober, and 1 year sober, and they found exactly the same amount of activity. It was only when they were 2 years sober did they actually see a decrease in this. But relative size, for being thirsty, dehydration, survival mode, it was a baseball. For food, survival mode, it was the relative size of a basketball. But for these drug addicts, even a year away from being sober and being clean, their fMRI, when they were asked to describe the first time they used and what it felt like, it lit up to being the size of a baseball field. That is how strong these addictions are and how much they are changing our brain chemistries. So this coming up is a little video about nicotine. It's created by an Australian company that helps you to quit smoking, but it really shows and exemplifies the importance of not smoking to begin with, and then how difficult it is to actually quit. Nicotine is an incredible.
Ever wondered what's going on in your brain when you puff a cigarette? This is a tale of two chemicals, the nice and the not so nice, and what happens when they meet. Nicotine is fast and it's sneaky. Like an Olympic sprinter, it races into the lungs. From the lungs, it enters the blood and reaches the brain within seconds of that first puff. The brain is made up of many cells called neurons. Nicotine actually affects pathways in the brain called the reward pathway. The reward pathway is a normal and important part to our survival. It's the area of the brain which makes us feel good every time we eat or do something we enjoy. Once nicotine arrives at this area of the brain, nicotine attaches itself to the receptor on neurons, like a lock fitting in a key, and this wakes up the reward pathway of the brain. This is where dopamine comes in, the nice chemical. When the reward pathway is activated, dopamine gets released and we feel warm and fuzzy and satisfied. However, too much repetitive stimulation of the reward system can be dangerous, especially with nicotine. Nicotine hijacks the reward pathway, attaching to a nicotine receptor to release dopamine and convincing the brain that we need another cigarette. Every time we smoke, we get that feeling of reward, and so we do it more. This sets up an unhealthy pattern as nicotine tricks the brain into activating those warm and fuzzy feelings with every puff. This causes changes in the brain over time. The longer you smoke, the more and more receptors are created, and each one is craving its nicotine fix. Over time, the body learns that it needs nicotine to feel good, but it can never get enough. That's why it's so hard to quit. The longer we smoke, the stronger the cravings for nicotine become. With no nicotine to bind into nicotine receptors, the reward pathway is not stimulated anymore. This means there is less dopamine. With less dopamine, people get withdrawal symptoms. The good news is that these changes in the brain start returning to normal the longer you go without a cigarette. Getting past the first stage of withdrawal when you quit can be hard, with lots of empty nicotine receptors screaming out for their fix. But the good news is that over time there are fewer and fewer nicotine receptors as your brain goes back to the way it was before you smoked. If you need Ever wondered what's going on in your brain when you puff a cigarette? This is a tale of two chemicals, the nice and the not so nice, and what happens when they meet. Nicotine is fast and it's sneaky. Like an Olympic sprinter, it races into the lungs. From the lungs, it enters the blood and reaches the brain within seconds of that first puff. The brain is made up of many cells called neurons. Nicotine actually affects pathways in the brain called the reward pathway. The reward pathway is a normal and important part to our survival. It's the area of the brain which makes us feel good every time we eat or do something we enjoy. Once nicotine arrives at this area of the brain, nicotine attaches itself to the receptor on neurons, like a lock fitting in a key, and this wakes up the reward pathway of the brain. This is where dopamine comes in, the nice chemical. When the reward pathway is activated, dopamine gets released and we feel warm and fuzzy and satisfied. However, too much repetitive stimulation of the reward system can be dangerous, especially with nicotine. Nicotine hijacks the reward pathway, attaching to a nicotine receptor to release dopamine and convincing the brain that we need another cigarette. Every time we smoke, we get that feeling of reward, and so we do it more. This sets up an unhealthy pattern as nicotine tricks the brain into activating those warm and fuzzy feelings with every puff. This causes changes in the brain over time. The longer you smoke, the more and more receptors are created, and each one is craving its nicotine fix. Over time, the body learns that it needs nicotine to feel good, but it can never get enough. That's why it's so hard to quit. The longer we smoke, the stronger the cravings for nicotine become. With no nicotine to bind into nicotine receptors, the reward pathway is not stimulated anymore. This means there is less dopamine. With less dopamine, people get withdrawal symptoms. The good news is that these changes in the brain start returning to normal the longer you go without a cigarette. Getting past the first stage of withdrawal when you quit can be hard, with lots of empty nicotine receptors screaming out for their fix. But the good news is that over time there are fewer and fewer nicotine receptors as your brain goes back to the way it was before you smoked. If you need help kicking the habit, call QUIT.
Help you. Okay. So Dr. Contessessa came and talked to my class in 2023, and he had some really key facts that I wanted to share with you. That drug addicts take drugs to avoid feeling bad, not just to feel good. because that dopamine levels have decreased so much that those withdrawal symptoms are really horrendous. And they're things like sweats, nausea, intense headaches, you get the jitters, and it's all you can think about, right? So they seek out these drugs just to feel normal, not necessarily to get high. Okay, and here's a crazy thing. The more exposure to a substance, the more receptors are created, right? Just like we saw. And this is the case for all addictions, not just substances. Alcoholics, even when they've had their last drink, they are always recovering alcoholics. Even after years of not drinking, they still consider themselves at risk for relapse. The programming of addiction is so deeply ingrained that it can lead to a full-blown addiction with just one drink and a relapse of a drink. So if they're cheersing at a wedding and they drink one glass of champagne, that could just set them off for the whole thing and trigger it all back again. So an alcoholic is always going to be a recovering alcoholic when they get sober. Same thing with drug addicts and the like. One of the big issues that's coming out is fentanyl. Fentanyl is horrendous. It is a highly potent opioid. It is 30 times more powerful than some medicines and hundreds of times more powerful than Vicodin. Whoa, that's horrendous. Even a tiny amount of fentanyl can cause addiction, withdrawal, and overdose. There are cases whereby people that have overdosed on fentanyl and somebody calls an EMS, the emergency responses, that they responders from just doing CPR and touching them have overdosed on the fentanyl by touch. It's crazy. It's so bad. And unfortunately, it is being laced into drugs and like street drugs, and just no. Just don't do it. Okay, quite simple. There are all sorts of different types of addiction, and it does the same thing. It changes our brain. It changes our brain chemistry. Exposure to these addictive substances can create permanent, hear me when I say permanent changes in the brain. Now, if there is a genetic predisposition for addiction, so you've got a parent, a grandparent, or somebody that may have an addictive personality, there is a higher chance that you would then also have a higher risk of addiction, and you're more susceptible to it. And here's the other kicker. The earlier you start with these addictive changes as substances, actions, the more likely you are to cause these permanent damages and permanent changes to your brain, which can then likely cause more addictions. Okay, well, this is where I'm going to tell you, and I'm going to drop my truth bomb. I'm an addict to coffee. I have to have my coffee every day. And I know that I am an addict to coffee because if I don't have my coffee, I will be a grumpy person until I get my coffee. I will get cloudy head, foggy, I will get a headache, and I will just be miserable. And I have to have my coffee in order to stop these terrible symptoms. It's not that I do enjoy coffee, but it's like I have to have it. So first thing in the morning, as soon as I get to the kitchen, the first thing I do is I'm going to brew myself a cup of coffee because that is what I do to prevent these withdrawal symptoms. I enjoy the cup of coffee, but it is an addiction. Same thing with other addictions. So I know that I am addicted to coffee. So I'm careful that I don't overindulge in it, and I don't have more than 2 cups a day, and that I'm aware that this is an addictive behavior, so that other choices I make I can curtail those, okay? Coffee, I've been drinking coffee and tea since I was little, so no wonder I've got a very strong addiction to coffee. Okay. So this is the other reason why we need to put our phones down and away, is because our phones are highly addictive. And they're designed to be. They're designed to release this dopamine. They're designed to give you this immediate response and to give you a boost of dopamine. Have you ever noticed that you've scrolled on whatever for hours and you're like, I don't know why I'm doing this. This is boring, right? Nothing's giving you pleasure. At first you're like, whoa, a phone. And now you're like, oh, my phone, I can't be without it. And it is an addiction, right? There is a movie called The Social Dilemma, and I would recommend you watch this with your family because it is so important for you to understand that it is, if they're not selling anything, the thing that's being sold is you, right? You are the addicted thing. And people with the like buttons, the people that invented it, really regret that they invented it. Like there is so much that goes on with this, right? So really, really, really realize that your phone and everything that's in it is addictive. And the more likely you are to make these addictive choices now with your phone, the more likely you are to set up bad chemical pathways which lead you to more predisposed to making up other addictions and addictive choices and down the road. Yikes, right? So if you have the ability to say no to your immediate cravings, like put the phone away, don't go for that extra cookie, don't, whatever it might be, this helps you to actually regulate your dopamine levels back to a normal one so that when you do actually have 5 minutes that you can have a look on Snapchat or whatever it might be, it actually makes you happy rather than feeling like you have to. Okay. Now, if you've been interested in this topic, there is a whole bunch more information about brain chemistry, addictions, and all sorts of things about the teenage brain. And I highly recommend you go and have a look on the topics page for the brain chemistry and addiction links. Perhaps you could use those as a source of extra credit. Ooh. Okay, so let's fill it in. Fill in the blank. Exposure to addictive substances or actions can create changes in the brain. What would that be? Okay, I think we're done with the brain. Well done. So up next, don't forget that you need to make sure that you are watching the sheep brain dissection and the cow eye dissection. Don't forget that you need to use plain unlined paper and pencil. If you use lined paper or pen, it's an automatic 0, so don't fall into that trap. Make sure your drawings are at least half a page and you label them and so on and so forth. Take copious quantities of notes, and then you've also got a brain to build with clay. So all good stuff. Again, if you need anything, let me know. And make sure you're taking a good brain break, giving yourself some good time, exercise, go in the sunshine, take some good deep breaths, put into action what you've learned today with your VARC and with your note taking and realizing how your brain actually functions. And if you're still with me and you can breathe a sigh of relief, give me a high five. Woohoo! Well done. You're doing great.